Welcome back to the deep dive. Today we are doing something that it feels a little bit like looking at a map of the world and realizing we've completely ignored the oceans.
Right.
We usually look outward,
Yeah.
technology, history, the economy. But today we are turning the lens inward.
Literally inward.
Literally, we are taking a tour of a microscopic universe that exists right now inside of you.
It is a universe. And quite frankly, it's a universe that runs the show a lot more than our egos would like to admit.
I have to say, going through this stack of research, and we're talking papers from Nature Microbiology, reports from Frontiers in Microbiomes, and some really startling new data on diet and aging,
Right.
it feels like a fundamental shift
A huge shift.
in how we even define what a human being actually is. It's not just eat your yogurt anymore, is it?
No, it's definitely not just about digestion. Not anymore. The scientific community has moved toward a term that I think really captures the magnitude of this, the holobiont.
The holobiont. I'll be honest, when I first read that in the notes, it sounded like something from sci-fi.
Like a cyborg.
Yeah, a cyborg. Or maybe a transformer.
In a way, the cyborg comparison isn't actually too far off. The concept of the holobiont is the recognition that a human is not a single genetic entity.
Meaning what exactly?
It means you, sitting there right now, you are not just one person. You are a host combined with, well, trillions of microorganisms, bacteria, viruses, fungi, archaea. We are all essentially walking, talking ecosystems.
So when I look in the mirror, I'm seeing the host, but I'm missing the majority of the residents.
You're missing the party happening inside. Exactly.
Yeah.
Think of yourself less as an individual and more like a coral reef.
Coral reef, okay.
A reef looks like a single rock structure, right?
Yeah.
But it's actually a massive living colony supporting this incredibly complex community of other life.
And everything depends on everything else.
Right. If the coral dies, the fish leave. If the fish leave, the coral dies. That is you. You are the reef.
That is a very humbling thought. But I want to get into the scale of this partnership because the context you provided in the pre-show notes, that really blew me away. We always talk about genes as the blueprint.
The blueprint for who we are, yes. And humans have about 20,000 genes in our own genome.
That's the instruction manual for building me, my blue eyes, my height, my liver function.
Exactly. But the microbiome, that community of microbes living in your gut, on your skin, in your mouth, they have a collective genome.
And how big is that?
It contains about 100 times that amount of genetic material.
Wait, say that again? 100 times.
100 times.
So you're telling me that genetically speaking, I am 1% human and 99% microbe.
Effectively, yes. From a purely genetic standpoint, you are overwhelmingly microbial.
That is insane.
And those microbial genes aren't just sitting there doing nothing. They are coding for proteins, for enzymes, and for signaling molecules that your body uses every single second.
So they're not just passengers.
They're not passengers. They act as an essential organ. We literally cannot live without them. I mean, they digest food, we can't, they train our immune system, and as we're about to see today, they might even be deciding what you want for lunch.
And that is our mission for this deep dive. We're going to decode how this inner universe controls everything from our sugar cravings to our wrinkles, and of course how we can hack it, or at least, stop destroying it.
Which is just as important.
But before we get to the hacking, I have a bone to pick with you.
Oh, go on.
Well, not with you personally, but with science generally, because there is a statistic that I feel like everyone knows.
I think I know which one you mean.
It's the classic dinner party fact. Bacteria outnumber human cells 10 to 1. It's in every biology textbook.
Yeah.
It's in every yogurt commercial. But looking at our sources, this study by Sender and his team, this is just wrong.
It's a myth, a complete myth.
How does a scientific fact that big that everyone repeats turn out to be a myth?
It's one of those things that just got repeated so many times it became truth. But it was actually based on a back-of-the-napkin estimation from the 1970s.
So not exactly high-tech.
Not at all. And the original calculation made a huge error. It assumed that the density of bacteria throughout the entire digestive tract, from your throat all the way to the end, was the same.
Oh, I see.
And it assumed that density was the same as the density in the colon, which is the most packed part.
That's like assuming the population density of the entire United States is the same as Times Square on New Year's Eve.
Precisely. It massively, massively inflated the numbers. So Sender and his team did a much more rigorous accounting. They took a standard reference man, about 70 kilograms, 20 to 30 years old, and they actually counted properly this time.
Okay, so give us the real score. What's the truth?
The truth is we have roughly 30 trillion human cells.
30 trillion.
On the bacteria count, it's about 38 trillion.
Okay, so 30 trillion versus 38 trillion. That's not 10 to 1. That's it's almost a tie.
It's a ratio of about 1.3 to 1. It's pretty much a 50-50 split.
I don't know if that makes me feel better or worse. On one hand, I'm not vastly outnumbered anymore.
Right.
On the other hand, it feels, I don't know, more intimate. Like, we're in an equal partnership here. This isn't an occupation, it's a co-op.
It is the partnership. And here's a detail I love from that paper. The ratio isn't even static.
What do you mean?
Well, because the vast majority of those 38 trillion bacteria are concentrated in the colon. It's like a bacterial metropolis down there.
Yeah.
And because we shed so much biomass when we go to the bathroom.
I think I see where you're going with this. This is a bit personal.
The ratio can actually flip temporarily after a bowel movement.
You're telling me that for a few hours after I use the restroom, I might technically be more human than I am bacteria?
For a little while, yes, until they replicate and catch up again.
It gives a whole new meaning to the phrase, feeling like yourself again.
It really does. But we shouldn't let the lower number fool us. Just because they don't outnumber us 10 to 1 doesn't make them less important.
If anything, it makes them more important.
I think so. The fact that we have co-evolved to maintain this almost perfect 1 to 1, 1.3 to 1 balance, it suggests just how critical this symbiosis is. We aren't overrun by them, we are synced with them.
Okay, so we are synced. We are partners. But in any partnership, you have to ask, who is really in charge? Because the most, I don't know, disturbing part of this research for me was section 1, what we're calling the puppet masters.
Mm-hmm.
We like to think we have free will. I choose the donut. I choose the salad. But the research suggests otherwise.
This brings us to the gut-brain axis, and I want to be very clear. This isn't a metaphor.
It's not just a saying.
No. When people say, listen to your gut, that's usually, spiritual advice. Biologically, it's a literal command structure. There are physical and chemical phone lines connecting your gut directly to your brain.
And it's a busy line.
Extremely. There are 3 main channels you need to understand. First, you have the neural channel. The big one is the vagus nerve.
The vagus nerve. I hear this term a lot in wellness circles now. Tone your vagus nerve. What is it actually doing?
Think of it as a super fast bidirectional fiber optic cable. It runs from your brainstem down your neck, wraps around your heart and lungs, and plugs right into your abdomen.
So it's a direct line.
The most direct line. It's transmitting physical and chemical data instantly. If your gut is in pain, or if it detects a toxin, or even if it just senses the texture of the food you ate, the vagus nerve texts the brain in milliseconds.
So when people say they have a gut feeling about something, and that's biologically accurate, they're sensing something through that nerve.
100%. That's the first channel. Then you have the endocrine channel hormones.
Okay.
Your gut is the largest endocrine organ in your body. It produces hormones like ghrelin, which travels to your brain and says, I'm hungry, feed me.
And on the flip side.
On the flip side, it produces hormones like GLP-1 and PYY, which scream, I'm full, stop eating now.
And we're hearing a lot about GLP-1 these days with the new weight loss drugs like Ozempic.
Exactly. Those drugs are just hijacking or mimicking a system that your gut is supposed to be running naturally.
Wow. Okay, so nerves and hormones, what's the third channel?
The third is the immune system. Your gut microbes are constantly talking to the immune cells in your gut wall. They can signal for calm or they can signal for war.
War meaning inflammation.
Inflammation, yes. And they do that by releasing these little chemical messengers called cytokines, which can travel through the blood to the brain and directly affect your mood and behavior.
Okay, so we have nerves, hormones, and immune signals. 3 different phone lines.
All buzzing with traffic all the time.
Now let's look at this specific mechanism regarding sugar cravings. Because this source from Nature Microbiology on Bacteroides vulgaris is just fascinating. Walk us through this, because this isn't just a vague, I like sweet things. This is a specific chemical chain reaction.
It is incredibly specific. It's beautiful, really. So researchers identified a specific bacterium called Bacteroides vulgaris.
Okay, one specific bug.
One specific bug. When this bacterium is present and happy in your gut, it produces a compound called pantothenate.
Pantothenate. That sounds familiar.
It should. It's basically vitamin B5.
Okay, so the bacteria in my gut are making vitamin B5. I thought I had to get that from food.
You get some from food, but your bacteria are a major production factory. Now, imagine a relay race. The bacteria passes the baton, the pantothenate, to the gut lining.
Right?
In the cells of your gut lining, there is a specific receptor protein. It's called FFAR4-free fatty acid receptor 4.
Sketchy name.
Very technical, but just think of FFAR as a lock. The pantothenate is the key.
Got it. Key in a lock.
When the key goes in the lock, FFAR4 gets triggered, and it tells the gut cells to release GLP-1.
The stop eating hormone we just mentioned.
The very same, but it gets more specific. That GLP-1 signal travels to the liver, which then induces another protein called FGF21, which then shoots straight up to the hypothalamus in the brain.
And what message does it deliver to the brain?
The message is incredibly specific. It says, we do not need sugar. It doesn't just say we're full. It specifically suppresses the desire for sweets.
It turns off the sweet tooth.
It flicks the switch to off.
So let's flip that. If I'm standing in the kitchen at 11 p.m., staring at a bag of chocolate chips, and I feel like I need them, not just want them, if I don't have enough Bacteroides vulgaris.
Or if you have low expression of that FFAR4 receptor, which, by the way, is very, very common in people with obesity and type 2 diabetes, that entire chain reaction is broken.
The signal never gets sent.
The phone line is dead. The stop signal never leaves the station.
So you think it's a failure of willpower. You're standing there thinking, I'm just weak.
Oh.
But actually, it's a missing bacterial signal. The call is coming from inside the house, but the phone's not working.
That's it. It completely changes how we view metabolic disease. It's not just a behavioral problem, it's an ecosystem failure.
And it's not just about hunger and cravings, is it? It's about mood. I was absolutely floored to see the stats on serotonin.
This is one of the most striking facts in all of modern neuroscience. About 90% of the human body's total serotonin is produced in the gut, not the brain.
90%. We take SSRIs, antidepressants, that target the tiny amount of serotonin in the brain. But the main factory is in the colon.
The factory is downstairs. Now, to be fair, the serotonin in the gut does different things. It helps with motility, moving food along, but the precursors and the signals absolutely influence the brain profoundly.
And it's not just serotonin.
No. Gut microbes also produce GABA.
GABA. What is that?
Gamma-aminobutyric acid. It is the brain's primary inhibitory neurotransmitter. It's the brakes. It calms you down. It's your body's internal Xanax.
And the bacteria are making it.
Specific strains, yes. They produce it, and it can travel up that vagus nerve we mentioned directly to the brain. So if your microbiome is out of whack, a state we call dysbiosis, you might not be producing enough GABA or serotonin.
So a bad mood might literally be a bad gut day.
The evidence for that is becoming overwhelming. Conditions like anxiety and depression are increasingly being looked at through the lens of gut health and inflammation.
That is wild. Okay, so if the bugs are controlling the cravings and the mood, the obvious next question is, what do we feed them?
The all-important question.
And this is where we get into what I'm calling the diet wars, because we have some conflicting info here, or at least some very nuanced info regarding keto and fiber.
This is a critical section because so many people are trying the ketogenic diet, low-carb, high-fat, and the impact on the microbiome. It's a bit of a paradox.
Okay, let's start with the good news for the keto crowd. What does it do right?
The good news is that when you go into ketosis, your body stops burning sugar and starts burning fat for fuel. A byproduct of this is the creation of ketone bodies.
Right.
One of them is called beta-hydroxybutyrate, or BHB.
BHB.
And BHB isn't just fuel, it also acts as a powerful signaling molecule. And one of the things it signals for is a reduction in inflammation, especially in the gut lining.
Okay, so less inflammation is always good.
Very good. Also, the keto diet, by its nature, tends to starve out some of the bad bacteria and yeasts that thrive on sugar.
Makes sense. You're cutting off their food supply.
Exactly. And interestingly, some studies show it can increase the abundance of a real superstar bacteria called Akkermansia mucinifila.
Akkermansia. I see that name popping up everywhere in longevity research lately.
It's a crucial one. It lives in the mucus layer of the gut and helps strengthen the gut lining. It's strongly linked to better metabolic health and lower inflammation. So in that sense, keto can be great for the gut.
But there's a but I can hear in your voice.
There is a big but. The problem is what we call the fiber gap.
Because if you cut carbs, you usually end up cutting out the major sources of fiber. Grains, fruits, beans, starchy vegetables.
All gone. And here's the golden rule you need to remember. Fiber is not just roughage to help you poop. Fiber is food. It is a prebiotic. It is what your good bacteria eat.
So if you stop eating fiber...
you are effectively starving your microbiome.
And who dies off first when the famine hits?
A group called Bifidobacterium. This is a key beneficial group, especially for infants, but important throughout life. We see a drastic drop in bifidobacterium in people on strict low-fiber keto diets.
And why does that matter so much?
Because bacteria like bifidobacterium take the fiber you eat and they ferment it. That fermentation process produces incredibly important compounds called short-chain fatty acids, or SCFAs.
The SCFAs.
The three main ones are acetate, propionate, and butyrate. And the most important of all of them is butyrate.
We mentioned BHB earlier from ketones, but this is just butyrate.
Right. Butyrate is the primary fuel source for the cells that line your colon, your colonocytes. It's what they eat to stay alive and healthy.
So it literally feeds your gut wall.
It feeds the wall, it reduces inflammation, it maintains the integrity of that gut barrier. If you cut out fiber, you stop producing butyrate, your gut lining starts to starve.
So you might be losing weight on keto, feeling good from the BHB, but you could also be starving your gut lining and killing off entire families of good bacteria.
That is the lazy keto trap. If you're just eating bacon, steak, and cheese, your microbiome is going to suffer. You might look good for a few months, but you're creating a serious long-term weakness in your ecosystem.
So what's the cheat code? How do we do keto without wrecking the gut? How to get the best of both worlds?
You have to be incredibly intentional about high-fiber keto. You can't just cut carbs. You have to actively replace them with fiber-rich, low-carb foods.
The outline gives us a nice list here. Avocados seem to be the MVP.
Avocados are fantastic. They are the perfect keto food, high in healthy fat, but also loaded with fiber. Then you have leafy greens, spinach, collard greens, kale. But you need volume. You can't just have a tiny side salad. You need a mixing bowl full of this stuff.
A mixing bowl of spinach. Got it.
Cruciferous veggies are also your best friend. Cauliflower, broccoli, Brussels sprouts, and seeds are huge.
Chia, flax, pumpkin seeds?
Yes, they are fiber bombs, but very low in net carbs. Plus, they contain healthy fats, so you're getting a double win.
What about things like coconut?
Unsweetened coconut meat or coconut flour, absolutely. And don't forget fermented foods.
Like sauerkraut or kimchi?
Exactly. That gives you the live bacteria, the probiotics to help repopulate things, in addition to the prebiotic fiber from the vegetables.
So the takeaway is, if you're doing keto, you need to be eating massive salads, putting seeds on everything, and adding fermented foods just to keep those bugs fed.
You have to be a fiber hunter.
A fiber hunter. I like that. Okay, so feed the bugs fiber where they starve. Now, let's move from the gut to something that I think will get everyone's attention. We talked about the brain. We talked about diet. Now, let's talk about vanity, the gut-skin axis.
This is where we really see the concept of inflammaging come to life.
Inflammaging. Inflammation plus aging. I love that word, even though I hate what it implies.
It's a perfect description of what's happening. So we talked about the gut barrier. When you have dysbiosis, that imbalance of good and bad bacteria, that barrier can get permeable. We call it leaky gut.
Right.
Now, inside your gut, you have lots of what we call gram-negative bacteria. And these bacteria have a toxin in their outer cell walls called lipopolysaccharide, or LPS.
LPS. I've heard this described as an endotoxin.
It is. It's a potent trigger for inflammation. And when the gut leaks, this LPS escapes from the gut into the bloodstream.
It just starts circulating around your whole body.
Everywhere. And this causes systemic, low-grade, chronic inflammation. It's not like a raging infection. It's like a constant low simmer of irritation.
And what happens when that irritation, that LPS, reaches the skin?
When it reaches the skin, it activates a family of enzymes called MMPs.
Matrix metalloproteinases. That sounds like a weapon system from a movie.
It acts like one. MMPs are enzymes whose job is to break down proteins. Specifically, in the skin, they break down collagen and elastin.
So they literally eat the scaffolding of your skin.
Exactly. Collagen is what keeps your skin firm and plump. Elastin is what keeps it bouncy and, well, elastic. MMPs just dissolve them. So the analogy in the notes is perfect. It's like a slow leak of sewage into your bloodstream that eventually degrades the foundation of your out.
Yeah, it is a vivid image. But it completely explains why some people spend a fortune on creams and serums, but if their diet is trash, their skin still looks inflamed and aged.
You cannot out-moisturize a leaky gut. If you have LPS swimming in your blood, your skin is under constant silent attack from the inside out.
Now, the skin has its own microbiome too, right? It's not just the gut affecting it from the inside.
Correct. The skin is its own complete ecosystem. You have a constant battle going on right on your face between the good guys like Staphylococcus epidermidis and potential pathogens like Staphylococcus aureus.
And what are the good guys doing to defend us?
They're producing their own short-chain fatty acids, just like in the gut, and they use these to maintain what's called the acid mantle.
The acid mantle. Sounds like a superhero cape.
It's a chemical barrier. Your skin is supposed to be slightly acidic, around a pH of 5.5. That acidity is hostile to pathogens. It blocks them.
And what happens if that gets disrupted?
If you disrupt that, say, with harsh soaps, over-exfoliating, or just bad internal health that changes your sweat chemistry, the pH goes up, it becomes more alkaline, and the bad guys can take over.
Is this directly linked to things like acne and rosacea?
Absolutely. Acne is strongly linked to high glycemic diet sugar again, which drives the insulin and IGF-1 pathway, but it's also very closely linked to gut dysbiosis. And rosacea is a condition of neurogenic inflammation, which has deep roots in gut health and those vasodilation triggers.
So the people who look young for their age, the so-called slow agers, it's not just their human genes.
Studies show that they invariably have a more diverse and stable skin and gut microbiome. Their ecosystems are healthier.
So the fountain of youth isn't a magic cream, it's a giant salad and a probiotic.
And crucially, avoiding the things that destroy the barrier in the first place. Which brings us to the saboteurs.
Yes. Section 4. This is important. We talked about what to eat fiber. Now we need to talk about what not to eat. And I'm not just talking about sugar. We know sugar is bad. There is a specific enemy identified here that is in, well, it's in almost everything processed. Emulsifiers.
This is truly scary stuff. We are talking specifically about things like carboxymethylcellulose, or CMC, and polysorbate 80P80.
And you see these on the labels of ice cream, salad dressings, almond milk, cottage cheese, bread.
They're everywhere. Their job is to keep oil and water mixed together. They make the texture smooth. They improve what the food industry calls mouthfeel.
But biologically, what are they?
They're detergents.
Like dish soap.
Essentially, yes. And what does detergent do in your sink? It strips away grease. In your gut, these emulsifiers strip away the protective mucus layer that lines your intestines.
The mucus layer that is supposed to keep the bacteria away from the actual cells of your gut wall.
Exactly. That mucus is the DMZ. It's the buffer zone. It keeps the peace. When emulsifiers dissolve it, the bacteria can come into direct physical contact with your epithelial cells.
And those cells are supposed to be sterile.
They are supposed to be sterile. This direct contact triggers an immediate massive immune alarm. It screams invasion, and that means inflammation.
So you're basically scrubbing away your internal protective lining every time you eat these common additives.
And the research shows the impact is fast and dramatic. CMC has been shown to reduce bacterial diversity. P80 specifically increases pro-inflammatory bacteria called gamma proteobacteria. It's a direct cause of leaky gut and is strongly linked to metabolic syndrome.
But here's the part of the research that really honestly chilled me.
Yeah.
The generational threat.
Yes, this comes from animal studies, so we have to be careful, but the implications are profound. If a mother consumes these emulsifiers during pregnancy, the offspring are born with altered microbiomes.
They inherit the damage.
They inherit a compromised ecosystem. The studies show they have a higher risk of obesity and metabolic issues before they even take their first bite of food.
That's terrifying. It suggests that our addiction to processed food isn't just hurting us in our lifetime. It's literally terraforming the biology of the next generation. We're passing down a broken system.
It completely redefines what we think of as heredity. We used to think heredity was just your DNA. You get your mom's blue eyes, your dad's curly hair. But we also inherit our mother's microbiome during birth. That's our starter pack of bacteria. If that starter pack is corrupted by these additives, the child starts life with a massive disadvantage.
Okay, that is really heavy. Let's pivot to something positive. We need a hero in this story. We need something to fight back against the saboteurs. And according to Section 5, the hero is a walnut.
A humble walnut.
What makes walnuts so special? I mean, I know they have omega-3s, but this seems to go a lot deeper than that.
It's not just about the nut itself. It's about what the bacteria do with the nut. This is the holobiont in beautiful action. Walnuts contain these polyphenol compounds called ellagitannins.
Ellagitannins, okay.
Now, your body, your own human cells, can't really absorb or use these very well on its own. They'd mostly pass right through. But your gut bacteria see them as food.
A feast.
A feast. They eat these ellagitannins and they convert them, they transform them into a super compound called urolithins.
Urolithins, so what do they do?
They are incredible. They are potent anti-inflammatories, they protect the gut lining, and they seem to improve mitochondrial health. They basically help clean up and tune up your cells.
So the walnut is just the raw material, but the bacteria are the factory workers turning it into the actual medicine.
Precisely. If you didn't have the right bacteria, the walnut wouldn't be nearly as powerful. It's a team effort. And the studies show that adding walnuts to the diet specifically increases the populations of beneficial bacteria like lactobacillus and roseburia.
And what does roseburia do?
It's a major producer of butyrate.
So it all comes back to butyrate. It's a prebiotic bomb.
It is. And there's also evidence for synergy with other nuts. A mix of Brazil nuts and cashews was shown in one study to improve gut permeability and increase anti-inflammatory bacteria.
So why are nuts in general so good for this?
Because their high polyphenol and fiber content is locked inside tough plant cell walls. This resists digestion in the stomach and small intestine. They make it all the way down to the colon, where the vast majority of your bacteria are waiting for a feast.
So eat your walnuts. Okay, let's zoom out to the big picture of disease. Section 6 connects all of this to one of the biggest health crises of our time: diabetes.
Type 2 diabetes is traditionally viewed as a problem of insulin and blood sugar. But if you look at the microbiome of a person with type 2 diabetes, it has a very clear signature.
A profile.
A profile, yes. Very low bacterial diversity, and specifically a severe lack of butyrate producers, especially a bug called Faecalibacterium prausnitzi.
There's that name again. It seems like you really, really want that bug in your gut.
You do. It's a cornerstone of a healthy gut. And without those bacteria, you get that metabolic endotoxemia we talked about earlier.
Let's review that cycle.
Bad bacteria take over, they release LPS, the LPS leaks into the blood, that causes systemic inflammation, and that inflammation directly blocks the insulin receptors on your cells. It causes insulin resistance. It's a vicious, self-perpetuating cycle.
But there are protective metabolites too, right? It's not just about avoiding the bad stuff. The good bugs make good stuff.
Right. Healthy microbiomes produce compounds like cinnamoyl-glycine and betaine, and these have been shown to protect blood vessels from diabetic damage and actually help insulin work better. So if you have the right bugs, you literally have these natural protective medicines flowing through your veins at all times.
So with all this knowledge, what is the future of medicine here? Are we moving beyond just telling people to eat more fiber?
We are entering the era of multi-omics and precision medicine. We aren't just guessing anymore. We are looking at very specific, targeted interventions.
I've heard about FMT, for instance.
Fecal microbiota transplant. It's exactly what it sounds like. Taking the entire healthy ecosystem from a healthy donor and transplanting it into a sick person.
To completely reboot their system.
To reboot the computer.
Yeah.
It's incredibly effective for certain infections like C. diff, but now they are doing trials for diabetes, obesity, even things like autism and Parkinson's. It's about resetting the entire ecosystem.
And what about probiotics? Is it more than just yogurt?
So much more. We're moving into next-gen probiotics. Instead of just the generic lactobacillus you find in yogurt, we are talking about using specific targeted strains like Akkermansia or F. prausnitzi as actual prescription drugs.
And what are postbiotics? That's a new one for me.
This is a fascinating area. The thinking is, if the bacteria are beneficial because they produce butyrate or urolithins, why not just skip the middleman?
Just take the butyrate directly.
Exactly. Why not just administer the beneficial metabolites directly? That's what postbiotics are. Cell lysates, SCFAs, things like that. This could be huge for people with very sensitive guts or compromised immune systems who might not handle swallowing billions of live bacteria very well.
So this has been an incredible tour. What does this all mean for the listener right now? Let's try to summarize this journey through the holobiont.
I think the core takeaway is a fundamental shift in identity. You are not a single entity. You are a partnership. You are a gardener tending a vast, complex, and vital internal garden.
And the numbers tell us it's a very balanced partnership, 1.3 to 1. We are in this together, almost equally.
And the control lines are real. The gut-brain axis means your cravings and your mood are not random. They are signals from that garden. The gut-skin axis means your reflection in the mirror is a status report on the soil quality of that garden.
And we have clear, actionable advice from all this research.
Avoid the saboteurs. It's probably the single most important thing. Read your labels. If you see carboxymethylcellulose, polysorbate 80, carrageenan, put it back on the shelf. It's a detergent for your gut.
And on the flip side, embrace the heroes.
Walnuts, seeds, a huge diversity of colorful vegetables, fermented foods, and If you are doing keto, you must do it right. You have to be a fiber hunter. Don't starve your pets.
I want to end on that provocative thought you mentioned earlier, the one that you said kind of haunts you, regarding the generational threat.
It's something I think we all need to sit with. We talk about heredity as if it's set in stone. I have my father's eyes. I have my mother's metabolism. But if our dietary choices today, like our constant casual consumption of these emulsifiers, are fundamentally altering the microbiomes we pass down to our children,
Than what we're struggling with now, we might be inheriting the dietary mistakes of the past generation.
exactly. And we are writing the biological legacy for the future. Perhaps heredity is less about the human DNA we pass down and more about the bacterial ecosystem we gift to our children at birth. If we want our children to be healthy, to be resilient, we have to fix our own ecosystems first.
That is a very powerful place to leave it. We are not just eating for ourselves. We are eating for the trillions of lives inside us and potentially for the health of the generations that will follow.
Absolutely. It's a profound responsibility.
Thank you for joining us on this deep dive into the holobiont. Go eat a walnut, check your labels, and treat your inner universe with some respect. We'll see you next time.